Hello friends, today I am going to talk about one of the interesting technique used by recent Qbot campaign. Malware author sometimes execute malicious payload by sideloading the DLL into legitimate application. One such a scenario I come across from the recent Qbot campaign. In this campaign, malware author using Windows 7 32-bit calculator application to load the malicious payload. Let's see how calculator application used to execute the malicious payload. This is the HTML sample. Basically, the HTML sample distributed using mal-spammed email. Once you open the HTML file, it will drop the password protected zip file. Okay, we can extract and we will check what inside the file. If we extracted, we can see there is the ISO file. If we extracted the ISO file, we can see there are four files inside the ISO file. Okay, so there are two DLL file. Then one is seems to be calculator application. One is seems to be Microsoft Edge application. Actually, it is not a Microsoft Edge application. It is just shortcut file, but it's pretended to be Microsoft Edge application using the this similar kind of icon. If you executed this shortcut file, what it will happen? Background, it will execute the calc file. Then calc file will try to load the Windows code cs.dll. Then Windows code.cll will try to load the malicious DLL. This malicious DLL will inject the explorer.exe. Then it will do the malicious activity. Let's see. If you right click that LNK file, go to properties. If you check the target, you can see this LNK file try to open the cmd.exe. That cmd from the cmd file, it try to open the calc.exe. Okay, okay. Now this calc is the not a malicious program. It's a legitimate application only. So, but how actually this legitimate application loading the malicious DLL? Here the trickiest question. If you understand how Windows is loading the DLL, then you will get an answer. You can see it from this picture. First, Windows loader try to load the DLL file from the memory. If it is not able to find the DLL from the memory, then it will check from the known list. If it is not from the known list, then it will check the application directory. After that, it will subsequently check the system32 system, Windows, and current directory and the environmental path. In this case, this is the legitimate application. First, it will try to load this particular DLL, this Windows core cs.dll. This file is the malicious file, but the name is the legitimate name from the Windows 7 32-bit OS. Okay. Whenever this calc program execute, it will try to load this particular DLL. From this image, you can understand this particular DLL file. It's not already loaded in the memory. It is not also present in the known DLL. Then what happen next? It will try to load from the application directory. That means from it will try to load from this directory. Okay. We will see how it's loading. I'm just going to open the process monitor. I applied the filter for the calc.exe. I just click the OK. Now I'm going to execute this LNK file. If you execute the LNK file, background it started executing. Okay, it's started executing calc program. Calc started executing the Windows code CS DLL. Then this DLL executed this malicious DLL. I'm just going to stop that malicious process. Now we will check what is inside the process monitor. If you see here, we will just come down. If you can check how it's loading the particular DLL file, or you can simply check the window, this name itself. So here it's loaded whatever DLL it required for the calculator application, it's loaded. After that, this particular DLL it's loaded from the application directory itself. In case this application directory there is no DLL with the name, then it will try to load from the system32 subsequently. But in this case, this is the name is the legitimate name, but the DLL is the malicious DLL. When the calculator load this Windows code cs.dll, what DLL will do background, it will load into the memory, then it will execute this malicious DLL. I will explain how it's loading. I'm just going to open this DLL using uh, X32 debugger. I'm just going to entry point. It will execute sequence of code. If you come here, the interesting thing is the create process. If you place the breakpoint here and execute it, if you execute, you can see the argument it's passing. In the argument, this DLL is trying to open the reg svr32.exe. The argument is the malicious DLL. Here also we can confirm it's already started this reg svr32.exe. That argument is that malicious DLL. Okay, this this is the way it's try to executing the malicious DLL using the legitimate program, legitimate calc program. Okay, now I have done the couple of tests. Okay, just open it. Okay, this is the process monitor log. Um, Directly executed this calc program without that DLL. Now see what it's loaded that DLL. So if suppose this particular DLL not present in the application directory, then what it will show here, it's name not found, right? So if it is name not found, then after that it will go to the system32 directory. Since it is the 64-bit Windows machine, it's using the syswow64 directory to load the particular DLL file. This is the case of this Windows 7 calc application. There is another one scenario also I tried. Okay, using the Windows 10 calc application. Whether if you open the Windows calc application, we will place the uh, Windows calc application in this folder. We will try whether Windows 10 application able to load the malicious DLL. So now what I am going to do, I just copy paste the Windows 10 calc application into customized folder path. Here I placed it. I'm just going to execute the calc program. Okay, I open the process monitor, apply the process filter as the process name calc.exe, and I'm trying to execute the calc. It's opened. Okay, I'm just closing. I'm just checking. There is the one particular DLL probe.sys the DLL. Okay, this is the one of the DLL. The program will try to load it from the current directory. Since there is no DLL in this particular current application directory, it's not a current directory, application directory, then it will subsequently it will try to load it from the Windows system 32 DLL. From that folder, it will load this particular DLL. Okay. Now what I'm going to do, this is the legitimate name, right? So I'm going to this legitimate name, I'm going to replace with the malicious DLL. Then we will execute whether this particular calc program able to execute the malicious payload. I'm just closing here. I'm going to replace this malicious DLL into legitimate name with the legitimate name. I'm copying that malicious DLL with the legitimate name into the folder. Okay, now I'm going to execute this calc. Now we need to observe whether this calc able to load this particular DLL, this particular DLL able to execute this malicious DLL, that we need to check. here. That is the malicious DLL. Okay. Now I'm going to open the process monitor. So I'm going to execute the calc program. Executed, it's opened successfully. I'm just closing. Now we will check the file name, the DLL name, prop.sys. If you find this particular calc program try to load this prop.sys, and in our case it's a malicious DLL, it's try to load, it's actually it's found, then it's try to map it. File is locked here. There is file locked only with readers, right? There is some error message. After that, it's try to load the legitimate DLL from the Windows 32 folder. So here what our observation is, the Windows 10 calculator application not able to execute the malicious DLL file. So why? Because whenever there is some of the mechanism used in the Windows 10 calculator application. So basically, side loading vulnerabilities specially occur when Windows manifest file not explicitly mention about the characteristic of the DLL, what DLL to be load. Okay, so in this Windows 10 application, they have some of the mechanism. Example, whenever Windows calc load this particular DLL, it will check some of the characteristic, whether it's having the proper import, whether it having the particular hash values, the proper, then some of the mechanism, it's a security mechanism it's following. Because of that only, even though it able to find the malicious DLL into application directory, but after that once it's loaded, that calculator application find this is the not a correct DLL to need to load, so it's ignoring this DLL. After that, it's loading the proper legitimate DLL from the Windows System 32-bit application folder. So this is the another scenario from the Windows 10 calculator applications. Thank you, friends. This is the just the information I just want to demonstrate. Thank you. Thank you for your time.